Okay, so here's another video going over integrals. Just some things that you need to get started, or just some things that you need to, be aware of, before you try to jump in and get down to the nitty gritty of actually doing integrals. In the last video, I gave you one little formula or one little property, which was the integral of, x to the n with respect to x is going to be equal to 1 over n plus 1 times x raised to the n plus 1 plus some constant. And, that's pretty much going to be, just a good rule of thumb to have. There's only one exception to where that really doesn't work, and, it's, covered by some other thing. But that's where your n cannot be equal to negative 1. And, that's because if you have, 1 over n plus 1, if n was negative 1, you would end up with 1 over 0, which, doesn't happen because that would be undefined. And, then as far as your x to the n plus 1, negative 1 plus 1 is going to be 0. Anything raised to the 0 power is, just going to be 1. So you would end up with something that's not defined times 1. And, how do you do that? For the purposes of this rule, it doesn't exist. All right, and then there's another property that I kind of touched on in the last video, but I really didn't explain it. So you're taking the integral of, some constant times a function with respect to, dx, where you could just pull the constant out front. And, like an example of that is if you're doing the integral of, 4x to the 5th with respect to dx, that's just pull your constant out front, which would be the 4. So you're going to have 4, and you're still integrating the x to the 5th dx. And so then up above, just, use the rule as before. So you'd have, 4 times, 1 over n plus 1, which is 6, times x to the n plus 1, which is 6. The dx goes away, and it's going to be some constant. And so that's going to be, 4 over 6, which is just going to be 2/3 x to the 6th plus some constant. So, you can see that, isn't really that complicated, just so long as you know what's, going on with it. Alright, another good thing to know is that, say you're taking the integral of like f of x, plus g of x, with respect to dx. You can, just simply break that apart and, just have the integral of f of x and just with respect to dx plus the integral of g of x with respect to dx. So, that's not very complicated. Same as before. So you're doing x cubed plus, 4, and just say x to the 4th, keep it easy. dx, that's going to be equal to the integral, kind of use that power rule or the first rule. So you're going to have 1 over your n plus 1, which in this case is our n, for our f of x, and this is going to be our g of x. So for the f of x part, we're going to have 1 over 3 plus 1, which is 4, x to the n plus 1, which is 4, and that's going to be plus the integral of, you can pull your 4 out front, or just keep in mind whenever you have, because you're going to have 1 over n plus something, and you're going to be multiplying that by 4. So you could just go ahead and, put do get rid of that. Way to get rid of that. But that's going to be plus 4 times 1 over our n plus 1. So that's going to be 5 x to the 5th. And out here we're going to have our constant still. So that's just going to be 1 over 4 x to the 4th plus 4/5 x to the 5th plus some constant.